Hello and welcome to the class on two-way analysis of variance. Analysis of variance is the appropriate statistical technique to be used in the situations where we have to compare more than two groups. One-way ANOVA is used for statistical analysis of a completely randomized design. In CRD, we have more than two groups, where only a single factor is operating, and therefore the data in CRD is classified only one way, that is column wise, and therefore there are only two components of variation between the groups and within the groups component of variation. However, the data can be classified in two ways, row-wise as well as column-wise. In case of randomized block design, a treatment factor and a blocking factor operates simultaneously. There could be various treatment groups, as well as there can be various blocks, and hence the data in RBD can be classified in two ways. Now, when the data is classified in two ways, as in case of RBD, where the data is classified using treatments and blocks, we have three components of variation: between the treatment means, between the block means, and the error component of variation. The data which is classified two ways is analyzed using a two-way analysis of variance technique. This is the skeleton of a two-way ANOVA table, where there are various columns such as source of variation, degrees of freedom, sum of squares, mean sum of squares, expected mean squares, and F ratio. The within component of variance is estimated based on within the group's mean sum of squares, whereas between component of variance is estimated based on between component of mean sum of squares. For estimation of mean sum of squares, we need to initially calculate various sum of squares, such as total sum of squares, between the treatments sum of squares, between the blocks sum of squares, and within the groups sum of squares. At this stage, treat sum of squares as a measure of variation. If we look into the formula of standard deviation, we can define it as the root mean sum of squares. The square of standard deviation, that is variance, can therefore be defined as mean sum of squares. Now, looking at the numerator of the formula of variance, what we observe is nothing but the sum of squares. And if we divide the sum of squares by respective degrees of freedom, we are likely to get mean sum of squares, which denotes nothing but the components of variance. Two-way ANOVA is the appropriate statistical technique to be used in case of randomized block design. In RBD, the term block is actually an extension of the term pair. Hence, RBD ANOVA is an extension of the term paired t-test. When we have a randomized block design with factor A and block B, we have T into R number of experimental units, and each cell will have many observations within itself. The stepwise procedure of RBD ANOVA involves setting up of null hypothesis, that is, stating that the treatments and or the blocks do not differ significantly. Calculation of total number of observations, as well as some of the basic calculations such as calculation of column total, calculation of row total, and calculation of grand total. Based on that, we can estimate the correction factor by taking grand total square divided by total number of observations. Next step includes calculation of sum of squares, the total sum of square, column sum of squares, the row sum of squares, and error sum of squares. ANOVA table is constructed using the column of the following entities, and the F ratio is calculated independently for the treatments and for the blocks. The initial decision will be based on comparison of the calculated F values with the respective table F values. If the calculated F value is less than the table F value, then the difference between the treatments or between the blocks is said to be non-significant, and the null hypothesis will be failed to be rejected. And if the calculated F value exceeds the table F value, then the differences between the treatments or between the blocks are said to be significant, and the null hypothesis will be rejected. If the null hypothesis gets rejected, we need to calculate the critical difference value. Critical difference value is the minimum difference value which is to be considered for significance of difference between any two treatment means. The critical difference values are estimated using the given formulas for treatments and blocks independently. Now, if the mean difference between any two treatments is greater than the value of critical difference, then the said treatments are said to differ significantly. Whereas, if the mean difference between any two treatment means is less than the value of critical difference, then the treatment means do not differ significantly. Same is applicable for the block means. Thank you.